Okay, we are here live at NeurIPS with two good folks. We want to cover the state of MechInterp basically, and you guys are very passionate. Mark, I had you on for AIE before. Welcome back.
Thank you.
And Jack, you're new, but also part of GoodFire.
Yeah.
How would you describe what do you guys do and your path into MechInterp? Maybe Jack, you want to go first?
So we do interpretability research primarily. We're a company focused on like making models interpretable and robust and safe. And I guess I would describe like the type of work we do as like the science of deep learning, which is trying to make models not just black boxes, like things that we can actually trust and like deploy in high stakes industries. And I guess my own path into interpretability was I was a PhD student from 2020 to 2025. I graduated in May, and I started I was working on language models. I was working on grounding in language models, which is basically the idea that you need more than text data to represent meaning in the world. And it was basically right away as I started, like at some point, GPT-3 had come out and I had a moment of like, oh, this is actually like, just really good at like understanding the world. And like, it was kind of a slow transition, but somewhere along the way in grad school, I switched to fully doing interpretability.
Cool. Yeah, so like Jack mentioned, GoodFire is an AI research company focused on building a platform for interpreting models of all kinds across lots of different modalities and domains. My path looks very different than Jack. So prior to GoodFire, I was at Palantir as an engineer on our healthcare team, and then joined GoodFire back in March. And I guess one cool thing about kind of the state of interpretability as a field and also how GoodFire is set up is there's a lot of foundational research still to be done that folks like Jack are working on in our team. But at GoodFire, I'm more focused on sort of like our applied real world use cases for Interp. So building out a platform that can help in use cases like scientific discovery, or for kind of like inference time monitoring of models for deployment in enterprises and things like that. So I think there's a lot of exciting, just totally new theoretical research to be done. But especially over the past year, I think we're starting to see interpretability have practical use cases be actually deployed in like, especially situations where models are being used for high stakes industries and problems, which is super exciting.
Yeah, I think a lot of people are ignorant of the fact that we're actually at this point where people can actually apply these things for real life use cases. I saw the platform directly. You guys had like a launch party in your office for the diffusion thing. Maybe you want to recap what that was so that people can go play around with it again.
Yeah. So this is kind of a research preview that we put out. It's at Paint.GoodFire.ai. It's live. That was a use case of interpretability for sort of like the creative domain. I think just giving one hint at like interpretability gives you a set of, I think of it almost as like power user tools for accessing models and doing things with them that you might not have realized you could. So that example is you take Stable Diffusion XL Turbo, so a model that typically you use text input to prompt the model and you get an image out. But using interpretability techniques, you can sort of like plug directly into the mind of the model and you get a 2D canvas where you can basically like paint directly into its mental map of the image. And so we used unsupervised techniques to basically figure out all the concepts that the model like has internally. So animals, backgrounds, scenes, and stuff like that. And so you can select any of those concepts, which again, were found totally unsupervised. And you can just like paint a lion over here and then drag it and move it over here. It's just a totally new way. Like this is a model that only takes text prompts as input, but when you plug into the brain, you can do these cool things.
Yeah. And then highlighting other work, because I think that one went relatively viral. Jack, I don't know if you want to take a turn at like other highlights of your year in terms of stuff that you shared.
You start with the memorization.
Okay, sure. Yeah. So there's a lot of work and like going back years on like, so models memorize a lot of their training data. That's a privacy concern, but it's also, I think, just scientifically interesting to understand. And there's sort of like an unclear picture of like, how should we think about how it's represented like within a model when is it like a computer with like a file system that we can kind of tap into where maybe files are redundantly stored, like, memorized training sequence are kind of spread throughout, or should we think about like some other way? And we kind of proposed a kind of like different lens on it. I think a exciting question around the work was whether we can like disentangle like core cognitive capacities in a language model from
knowledge, right?
knowledge.
I always think like GPQ QA 0
Mhm.
and IF eval 100.
Yeah.
Exactly.
Right. Right. So this is a paper we put out recently in October, and we showed there's this like nice spectrum of like capabilities in. So there's another new lens on memorization, which is that in language models it's not so black and white, like what is memorized and not. So like memorizing that the capital of France is Paris is memorized in some sense, but it's a lot different than just like memorizing like a single page like license agreement document that shows up 1,000 times in the pre-training data or something like that. You can actually see like the way that we like disentangle memorization. You can kind of see this like gradient of memorization in between both mechanistically and behaviorally, with like logical reasoning tasks being quite distinct from rote memorization, and then like factual recall is kind of somewhere in the middle.
What's your follow-on work after you've done this?
So I think like understanding like the reasoning capabilities is very interesting. I think like understanding how post-training affects those capabilities in general is super interesting, and I think we're going to keep pushing on that.
Can you induce forgetting
So
selectively?
we show, so there's a lot of work on like unlearning. I would describe it more as not unlearning, but maybe suppression. I think there's like really like, I guess, guarantees that you've fully removed information from a model is I don't think it's been convincingly showed anywhere yet. And I think that I think maybe some of the point that we want to make in our work is that when we look at memorization this way, it makes a point about how hard or possibly like intractable that is.
I don't know if this is a related problem or it's too different, but instead of unlearning, but updating. So I moved the capital of France to Marseille.
Yeah.
But there's so much training data saying the capital of France is Paris.
Yeah.
I need like a date. I need to be able to tell the model, hey, like this is now out of date. But like short of tagging a date on everything, I don't know when that makes sense. That's like a weird.
Yeah. A really big like paper from a couple of years ago on this exact thing on fact editing was the Rome paper. It's rank 1 model edit. And
Nice acronym.
yeah, very good. And they look at exactly what you're describing. It's a really nice paper. I don't think it's being used like in deployment anywhere, but I think that's like, and it's really an interpretability paper. And I think that's somewhere where like, from a basic science perspective, like interpretability has like so much to offer, is understanding how we can do something like that, which is currently just very difficult.
So call you over to Mark a little bit for industry stuff. What can people do at the end of 2025 that they could not do at the start of 2025?
So I'll preface this with saying we still have a long way to go, but we are excited about seeing like the seeds of things actually being deployed in practice. I would say that we're just continuing to make progress on understanding that models have a lot of latent capacity that you can't get at by treating them entirely as black boxes. So we're seeing interpretability show up in like model cards now for evals that people are running for various like red teaming exercises and stuff. Yeah, I know there's some stuff in Gemini 3, Claude, I think Claude 4, and it's definitely Claude. Yeah, for sure. I mean, yeah, the Interp team there is phenomenal, and I think works across some of their other teams. And then from GoodFire's perspective, so like one of our partners, Rakuten, is deploying an interpretability-based tool in production with one of their language agents. This is a really cool use case where what they needed to do was take chats between their customers and their agent, find instances where personally identifiable information is mentioned, so names, emails, phone numbers, things like that, and scrub it out. And interpretability turned out to be the best way to do this at scale and in a cost-effective way. It was both more effective and cheaper than alternative techniques.
And you do that by having like a PII feature?
Yeah, exactly. So what you do is the customer is talking with an agent, but then separately, you're putting that transcript through what we call like a sidecar model. Okay. And what's really interesting is if you ask that model, try to like use it as an LLM as a judge, it's not very good. But if you probe its mind and you sort of detect when the features related to personally identifiable information are firing, that gets you the highest recall of anything. It's the equivalent of using GPT-5 as a judge, but it's, like 500 times cheaper. So they're deploying that. And then I, am personally very excited about the use cases for scientific discovery. So some of our partners in the life sciences and in materials, there are these narrowly superhuman models for things like genomics, for medical imaging, for proteomics, for material science. And those are especially uninterpretable because they are working in domains that, we can't, well, they're huge, and like we can't I don't speak genome, like it's literally base pairs in, base pairs out, but they're superhuman at tasks that are very interesting. So we have some exciting early results in finding novel biomarkers of disease with some of our partners that we're excited to share soon. And I think AI4Science is, becoming a very hot topic, and I think for good reason.
Yeah, we're literally starting an AI4Science pod. Like we're spinning out the separate in-space AI4Science pod.
I love to hear that. Yeah.
Featuring other work done, notable work this year. I feel like I have to mention Entopic's circuit tracing paper. I don't know if there's much discussion internally for you guys, especially you, Riff. Like, what do you think?
Yeah, Jack, I know has done a lot of circuit tracing. You wanna?
Yeah, when that came out, we did so that was back in like
March
or April.
If you could, let's say people know about the SAE work.
Yeah.
What is the difference? Because I struggle summarizing it. My summary, you can correct me. It's like take an individual, like have a full access to the model. Take an individual layer and train a replacement circuit that simplifies what it does.
Yeah, so yeah, that's right. And a good way to maybe put it is that you take a representation in the middle, which is this like weird, dense, uninterpretable like web of concepts and features in a representation, and the SAE like decomposes it into like primitives, like concept spying for like mentions of coffee shops or mentions of like New York City or something like that. And those are much more interpretable. And but it basically it shatters the representation to like many pieces. The big change with the cross-layer transcoder, so the circuit tracing work, was to really scale up the models to incorporate like every layer. So like cross-layer, so the model is called the cross-layer transcoder. So it's incorporating like it's tying features across different layers. And then the tracing part is a method for creating like it's called an attribution graph through those features, which are interpretable to like describe how the model is like producing one output, like through every layer and through like a bunch of token positions. I could talk a bit more about it. So when that came out in like March or April, we so still pretty early for us. There were like 8 to 10 of us at the time, I think. So we tried to went ahead to replicate some of their findings. We're really curious about what would look like training one, like what it's like to use it, and basic scientific questions as well, which is like, could it rediscover some like rich representations from like previously understood circuits? So we put out a post. I don't remember when exactly that went up, but I think over the summer, like May or June, on our replication effort on that and like how that works.
Is there an obvious next step? Like what is this all leading up to? Because to me, it's like basically just always scaling it up, always making it more unsupervised. I don't know if there are other trends that you can see. Like, yeah, these are the core principles that we're just exploring.
That's like a good point to bring up interpretability as an alignment science versus as like a science for understanding models like more broadly, which is like if you
one in the same kind of.
I think it depends on what your motivations are. So if you are focused on reading a model's mind and understanding like maybe what's going on internally to make sure it's not having bad thoughts or like it's not misaligned, it makes a lot. It makes a lot of sense to like do exactly what they're doing. So I think they're just not there. I don't know exactly what they're up to, but applying like these techniques to like read out what's going on inside these models' minds. So it's a very nice detection like framework. But if we want like really robust control, like really robust control of models, like what they learn during training, I think like that's where there's so much more work to be done. I think many different teams are all working on these problems. But in terms of next steps, that's like some other directions to go.
Yeah, no, I think to Jack's point, I think the circuit tracing work is super cool, and I think it's sort of one arrow in a larger quiver of techniques that are useful, and what technique is useful depends on the task at hand that you're interested in. So to Jack's point, like the techniques that are useful for alignment science and evaluations, that's one use case, but there's a whole world of other things that you might wish to apply other techniques for. And maybe you don't need circuits for things that can be uncovered using probes or using other techniques to understand how, post-training changed a model. So this like model diffing use case, and maybe the things that you want to use as like inference time sort of guarantees for models look a little bit different. So I think it's super cool, but yeah, to your point, kind of like there's a variety of techniques depending on the final use case that you're interested in.
Last thing that a lot of people hear in NeurIPS, I've had like 2 conversations about it already, is what's happening with Neil Nanda. I don't like celebrity culture, but it's hard to avoid Neil's impact. And he basically said he's pivoting his team at DeepMind to no longer focus on whatever, and now it's like pragmatic interpretability. What's that conversation about? Like, what do insiders think?
I read Neil's post, and I think like I also share the hope that of a pragmatic future for interpretability for sure. I think a lot of the
why didn't we think of that earlier? We should have been pragmatic. Like, oh god.
I also think a lot of the response to that, I'm not sure that folks actually kind of read it all the way through. I think there's a lot of reading of that. For some reason, folks thinking, oh, like interpretability is dead or something. If anything, that says interpretability is alive and well. Like there are use cases for not black box techniques that can be brought to bear in real world use cases. So I think we probably agree with Neil on that. And then I think also good for like different companies to have different agendas that they're pursuing. I think it's dangerous. A field will stagnate if everyone sort of is just converging on the exact same approaches of things. Not sure if you have other.
To the point about like, is interpretability like dead or something, I think is like gross like misattribution of like what that post is about.
It's about your point. I'm not saying it. Nobody I talked to was saying it. It's just more like the existing approaches for him were not scaling to some extent. And he was, the way I put it is kind of like, it's like, well, okay, let's forget about complete understanding and let's manage by outcome. And like, let's measure ourselves by our ability to steer outcomes and forget if we know precisely what's going on.
Yeah, totally. So in terms of like, should we just be focusing on like reverse engineering models like from the ground up? So that's maybe where the big change is. I think like we probably agree that like interpretability should be useful, and we're trying to get it like used right now, and we are getting it used right now. I think like maybe where we kind of align on this is like we're really focused on like use case inspired like basic research. So yes, like we're very pragmatic, but there's also like a lot of like very deep foundational science to be done on understanding models, which is yes driven by outcomes, but we also want to like develop like the understanding of what goes on in models, because if we're not doing that, then every other like lab producing models is just a black box AI lab, and that's not how things should be done.
Jack snuck in a little reference there that I think was good. So there's this concept that we like to talk about internally called Pasteur's Quadrant. So Louis Pasteur, like,
is this like a statistical thing with like the same distribution but 4 different? That's ANSCO.
Yeah, no, this is more like a conceptual kind of framework. But the idea is that you can have, so the 2 axes of the quadrant are, I've heard it described as like discovery and invention, or like pure research versus applied research, like something in that kind of domain. But the idea is that you can have just pure basic research. And so the classic example there is like Niels Bohr, like understanding the atom, understanding the electron, just for sort of like theoretical physics interest. And then you have the corner that is just like purely applied research, purely you have an end in sight, which is like Edisonian research. So Thomas Edison says, I want to make a light bulb. I don't really like, I'll learn the chemistry that I need to, but it's just this goal is the goal. And then there's Louis Pasteur, who like spanned both of these. And so the idea is that it's not just this linear thing between basic research and applied research. You can kind of have a combination of those two. And so Pasteur, sort of pioneer of like germ theory, but also engineered some of the first vaccines. And so this idea that you should sort of be bouncing back and forth between kind of open-ended foundational research, but then also having a goal in sight and be able to really foot back and forth between the two. I think there's a lot of cases where you see this being a really productive way to make progress in a field.
So there's a company like Hero mascot.
I think it's Tom McGrath, one of the co-founders of GoodFire, who he started the Interp team in DeepMind back in the day, and he has a lot of these like great references from other domains of science that are just I think really good kind of grounding points for how we operate.
Amazing. Let's get a quick call to action in. You guys are hiring. What are you hiring for? What's hard to find?
Definitely actively hiring. I hope the AI engineer community should definitely go to GoodFire.ai, check out our careers page. Actively hiring for researchers and engineers. And
you can bounce.
Yeah, exactly. There's a combination. So yeah, we're doing foundational interpretability research, but we're building out a platform to apply this in real world use cases. Customers across life sciences, materials, government, financial services. So if you're someone with an MLE background, no Interp experience required whatsoever, you can see we have different backgrounds. I'm kind of coming from industry, from engineering. Jack's coming from a PhD. Other folks at GoodFire have backgrounds in like quant trading firms or frontier labs, all sorts of places. But if you like training big models, building agents, engineering systems, we're hiring across a variety of roles and really looking to fill some of those engineering gaps.
Excellent. I think that's it.
Yeah, love it. Thanks for having us on.
Thanks for coming.
Yeah.